Okay, when we were talking yesterday, we were talking a little bit about energy, and what I want to make clear at this point, okay, we're going to use this. Do you see why this is called conservation of mechanical energy? I hope that you can logically put that together by looking at what I've written. What's F? Final, right? So does that make sense? It's just energy doesn't change. Please be aware that there is another thing, right? This is conservative, which says MEI equals MEF. Then there is non-conservative, where you say MEI equals MEF plus work done by the non-conservative system, whatever. Or you can just say non-conservative work. Okay, non-conservative work usually is done by what? We heard you coming. Did you find it?
Sorry.
What is non-conservative work usually done by? What makes systems lose energy? There you go, friction. So this is usually the work done by friction. Usually. Okay, so here we're going to say MEI equals MEF. What kind of mechanical energy does this have to begin with? Oh my goodness. No one knows. It's moving, right? So it must have kinetic. Now, is that kinetic energy positive or negative? If that was pointed down, would it be negative? Why not? But if up is positive, isn't down negative? What did you say? Energy is relative. Close. You're on the right path, but it's not even that. What's the equation for KE? 1/2 mv squared. Is there a vector in that? What is the vector? If you say math, then if you say mass, you get bumped down to regular physics. What's the vector in 1/2 mv squared? Yeah, v for vector. Get it? V. So v is the vector. Velocity, right? What happens when you square a velocity? Yeah, what happens to the vector? Do you know now whether it's positive or negative? Do you see what I'm saying? If I put in a +5 or if I put in a -5, what happens? Yeah, it comes to the same thing. 25. Energy is a scalar. It does not point anywhere. There is no vector notation for energy. Okay, energy is not a vector. It is a scalar. It has no direction. All right, so we have KE. What else? Any other types of energy there? So any type of energy before the thing lands on the floor. Yeah, gravity. Where are you standing? On a cliff, right? You're like 60-something feet, almost 70 feet in the air when you shoot this cannon or whatever. So what kind of energy do you have? Potential energy due to gravity. Now, just before you hit the ground, okay, and this is the biggest mistake the kids make, because after I've hit the ground, what kind of energy do I have? Zero. I have zero kind of energy. I have no kind of energy. Because I'm at the lowest possible point in the system, and I'm not moving. So do you see how that creates a problem? You never think about after you've collided with the ground. You always think about just before. Now think about it this way. Do you care about anything after you've hit the ground from a very high height? No, it doesn't matter anymore, right? You now know whether or not there's a God. Right? You can answer all those questions that everybody's been longing to ask their whole life. You see, so your last moment of concern is before you hit the ground, right? No one, well, I don't know, are people afraid of dying? I think most people aren't afraid of dying. People your age, I don't think, are afraid of dying at all. I think you're just afraid of the pain associated with death.
It's not. Yeah, being dead is like, whatever. I just don't want all the hurting that happens before the dying happens. Yeah. But anyways, whatever. I don't know. Are you afraid of dying? You know, they did that thing in the Tongva Times about fears. Is when I was your age, and I think through college also, people's number one fear was public speaking. Now, see, I don't imagine that's a big problem at this school, right? With like whatever, a third of the school in speech or something. So, but yeah, that's usually a big thing. Oh, anyways, yeah. So, what kind of energy do we have just before we hit the ground? Just before we hit the ground. What are we doing? The nanosecond before we hit the ground, can we really fall any farther?
Yes.
Okay, whatever. Right, I'm not counting the femtometer that we're above the ground, right? Like, so just as, how about this? As we touch the ground, can we fall anymore? No. So what is it that's going to cause a problem? It's the energy that we have, but we have zero potential energy. Do you see that? Because we're touching the ground. But that's like as our first part of us touch the ground. But what's going to happen with the rest of us? Boom. So what type of energy does our body have? Kinetic. That's the key. We're moving still, right? And so then we just go 1/2 mvi squared plus mgh equals 1/2 mv final squared. All your m's cancel. V final is equal to the square root of vi squared plus 2gh. And if you look, that should be really familiar. So this becomes 50 squared, and this is 20 times 20 is 400, so this is 30.